Okay, we're just doing locus. We're starting off with the locus. So the first bit is describe the locus of the following. Now the whole point is that the locus is the path that it takes, not the point where it's rotating around. So describe the locus or the path of a pencil on the end of a compass or a pair of compasses. It is circle with the center at the point of the compasses. Awesome. So that's pretty straightforward. And yeah, it's also, you could say it's the width, the radius is the distance between the point and the pencil. All right, what would be the locus of a person going up an escalator standing still on one step? So we're not trying to draw it, we're trying to describe it. What would it be? Don't try and go mathematical on us. At the moment, we're not trying to go all mathematical. Just describe what the locus would be. Would it be a circle? Okay. Would it be a wiggly line? Wouldn't the line look kind of like that? Because they're standing there and oh, that's elevator music, not really good. You go up. Wouldn't you say that those two lines are parallel to each other? So you could say that that is, probably say A rather than the. Parallel. Oh, look, I'm dragging down. Yeah. Parallel to. Does that make sense? It's just a line parallel to the escalator, yeah? Cool. Because that's the movement. You've got to think about what the movement is. And it was in relation to going up an escalator. Now you could, they've also got the little thing, what would be the locus if the person was walking up the escalator? Just think about that. Next one is a doorknob. What would be a doorknob? The locus of a doorknob on a closing door. Sometimes you need to draw a picture. There's your door. What's your doorknob going to do? Parabola? Okay, just imagine that that door wasn't really a door, it was on a pole. What shape would the door do as it went around the pole? It'd be a circle. So your doorknob sitting there, what's your doorknob, oh that's terrible, going to do? It'd make an arc, because it's not going to go the whole way around. Can you see that? I could have done this. No one on the interweb can see this. But there's your doorknob. What shape's it doing? It's just doing part of a circle. If we went 90 degrees, you've actually got the arc of the quadrant of the circle that it would pass in, yeah? That make sense? Yeah, and sometimes that's what is sort of difficult. Yeah, the doorknob itself, the locus of the doorknob possibly be a circle, but yeah, with the doorknob on a closing door, it's going to be an arc. Oh, that's the wrong one. An arc. Last one on this one. A point on the number line that is, oh, there's two more, is 3 units from 0. A point on the number line that is 3 units from 0. Now remember, this is on a number line. It's not three-dimensional. It's not even two-dimensional. It's one-dimensional. Okay, so think about a number line. There's 0. That's -3. That's 3. This is getting a bit more mathematical, Tyler. Yeah, pretty much. Yeah. That point is 3 below it. That point is 3 above it. Does that make sense? So the locus is -3. I should actually just do plus or -3. Okay, that's starting to get a bit more numberish. Now, but that was only one-dimensional. We're talking about a number plane. We're now moving into the realm of 2 dimensions. So we're now talking about a point on the number plane, in the number plane, sorry. Not on, it's in the number plane. We're not on a number line. We're now 2-dimensional. That moves so that it is always 3 units from the y-axis. Yep. It's just 2 points, yeah. If that's part of its conditions, yeah. So you can have like an arc, you could have it only that side, or you could have it that side and for whatever reason then miss a bit. Yeah, if that's part of its conditions, then yes, it can break. It doesn't have to be continuous. Huh? Yeah, swinging door, but I'm trying to think of a good example. And I can't. I'll think of one later. Okay, this one is a point in the number plane that moves so that it is always 3 units from the y-axis. Now think, we're on number plane this time. So I've got 2 dimensions. So I've left the diagram up there. So there's 3 units above and below the 0. So what would the locus be? Well, what's it going to look like? What's the locus going to look like? I think you should. That's correct. What does the locus look like in this case? Remember, we've gone from just objects and people and doorknobs. We're now starting to get more towards my goat example, where the locus was a circle, which is a mathematical figure, a 2-dimensional figure. What's this? What is the locus going to look like? But they're going to be lines, right? They're going to be vertical lines. And where are those vertical lines going to be? They're going to be at x equals -3 and at x equals 3. Because they're both the points that are 3 units away from 0. Cool? So we now have 2 lines. X equals 3 and x equals -3. Okay, so it's 2 vertical lines. Happy with that? Excellent.